Bridges, section 6.6, solving rational equations. So basically, we've been working with all these rational functions, or rational expressions. Now we're going to have them in an equation that we're going to have to solve. So for instance, 3 over 5 equals x over 2 plus 1. Well, the scary thing about that is that it's got fractions in it. So what we're going to do is we're going to clear those fractions. Clear fractions by multiplying by the common denominator. So what you have to do is you have to determine what the common denominator for any particular problem is. And so, as I look at this, I've got a denominator of 5, a denominator of 2, and essentially a denominator of 1 on the 1 there. So the common denominator between 5 and 2 would be 10. So what I'm going to do is I'm going to multiply 10 times 3 over 5, 10 times x over 2, and 10 times 1. Now, 10 divided by 5 is 2, so 2 times 3 is 6. 10 divided by 2 is 5, so that would be 5x plus 10. And now at this point, all you have to do is solve this equation. So I can subtract 10 from both sides. Negative 4 equals 5x, divide by 5. X equals negative 4/5. X minus 3 over 6 equals 7 minus x over 12. Again, we look for the common denominator. Common denominator would be 12. So, if I take this times 12, so I take everything times 12. Let's see how this works. So 6 goes into 12 twice, and then I distribute the 2 to the x minus 3, so I get 2x minus 6. 12 times 7 is 84, minus x. So then what I can do is I can solve this equation. So I can add x to both sides. I can add 6 to both sides, and I get 3x equals 90. Divide by 3, x equals 30. So let's look at this one. You should already be looking for a common denominator. Common denominator is 6. Hopefully you see that. So anyway, what we end up with is we end up with 2x squared plus 3x equals 5. Now hopefully you realize that that's quadratic, and therefore we need to try to factor it or do this quadratic formula. Either way, it's got to be equal to 0. So we move the 5, 2x squared plus 3x minus 5 equals 0. And then we factor it. multiply going across the bottom. It's negative 10x squared. What multiplies to give me negative 10 but adds to give me 3? That would be 5x and negative 2x. Greatest common factor between that guy and that guy would be x. X times 2x is 2x squared. That's a 5, and that's a negative 1. So you do this little butterfly thing, get your two factors. So x minus 1, 2x plus 5. And remember, at this point, I say x minus 1 equals 0. I can add 1 to both sides. X equals 1. Or I come over here and I say 2x plus 5 equals 0. I subtract 5 from both sides. 2x equals negative 5. That's an equal sign. Divide by 2. So x equals negative 5 halves. So that one has actually two answers. All right. So let's see what happens when we start putting variables in the denominator. So if I look for a common denominator here, I've got an x, a 3x, and a 3. So the common denominator between those would be 3 times x. So in each spot, I'm going to multiply by 3x. Now, on this first one, the x cancels out. 7 times 3 is 21. Minus. On this one, the 3x cancels out, and I get 1. And that equals, this time the 3 cancels, and I get 8x. So 20 is equal to 8x. Divide by 8. 20 over 8 reduces to 5 over 2. 5 halves. Now, here's the key with problems that have a variable in the denominator. You must check for division by 0. So in other words, I've got to take this guy right here, and I've got to plug it in to that x and that x, and make sure that it doesn't equal 0 on the bottom. Well, 5 halves itself is not 0, so that one's taken care of. And 3 times 5 halves is certainly not 0, so that one's taken care of. So in reality, this is an answer. Wow. All right. So, let's continue. Can you see what the common denominator is? Considering the fact that the 7 is essentially 7 over 1, hopefully it's fairly clear that the common denominator would be x minus 2. So I'm going to take each piece of this, multiply it by x minus 2. So all those cancel, and I have 5x equals, I distribute the 7, so I kind of do that kind of thing. 7x minus 14 plus 10. So that means I've got 5x equals 7x minus 4. I can subtract 7x from both sides. Negative 2x equals negative 4. Divide by negative 2. And I get x equals 2. But I need to check that to see if it causes division by 0. So I take my 2 and I plug it in there and there. 2 minus 2 is 0. And 0 on the bottom of the fraction is very bad. Division by 0. So what that means is that this is actually not a solution because it causes division by 0. And so that's actually what's called an extraneous solution. And since that was the only answer we got, that means that there's no solution to this problem. Now, do you notice that basically this is just one fraction equals another fraction? Oh, that was a mistake. But anyway, so, fail. Anyway, because this is just one fraction equals another fraction, you can actually cross-multiply this. So I multiply those two together, and I'm going to multiply those two together. So what that means is that 2x times x minus 1 equals 3 times x plus 4. I can go ahead and distribute. So this would be 2x squared minus 2x equals 3x plus 12. I can move the 3x and the 12. And I get 2x squared minus 5x minus 12 equals 0. I hope you're thinking about factoring that, because that's what I'm thinking about. See if we can get this factored before time runs out. This would be negative 24x squared. What multiplies to give me negative 24, but adds to give me negative 5? That'd be negative 8 and 3x. Greatest common factor between that guy and that guy is 2x. So that'd be x, negative 4, and 3. So, to solve this, you've got 2x plus 3 and x minus 4. 2x plus 3 equals 0. 2x equals negative 3. So x equals negative 3 halves. X minus 4 equals 0. At 4, x equals 4. And we have to check both of those. So let's look at negative 3 halves first. So negative 3 halves plus 4 is not 0. Negative 3 halves minus 1 is not 0. So I plugged it into both spots, both here and here, and neither one of them gave me 0. Therefore, this is a good answer right here. And let's try 4. 4 plus 4 is 8, so that's not 0. 4 minus 1 is 3, so that's not 0. So neither of these cause division by 0. So they would both be valid solutions to the equation. I have one more example. We'll do it in the next video. See you there.